Hello friends, today we are going to solve yet another numerical from the lesson solutions. So let's begin. A 0.15 molal aqueous solution of KCl freezes at minus 0.510 degrees Celsius. That means molality is given 0.15 molal. The solution is of KCl and the solution is freezing at minus 0.510 degrees Celsius. That means this is TF given. Now what we have to calculate is I and osmotic pressure, that is pi at 0 degree Celsius. So we have to find out I, then pi, and pi has to be at 0 degree Celsius. The solvent is water and the freezing point of water TF naught is 0 degree Celsius. So that we can find out delta TF, which will be equal to TF naught minus TF, that is 0 minus of minus 0.51, that comes out to be 0.51. Here we can write either degree Celsius or Kelvin. Here I prefer to write Kelvin. Now since it's a difference, that is delta TF, so we can use both the units, degree Celsius as well as Kelvin. The next thing what we are going to do is find out delta TF again by using another formula, Kf into m. Kf stands for cryoscopic constant and for water the value is 1.86 Kelvin kg mole inverse. So Kf, that is 1.86 multiplied by molality, which is given 0.15. Here we can multiply it directly and we get the value as 0.2790 and the units can be Kelvin. Now since we are having two values, observe for delta TF. One is this one and the other one is this one. So one of them can be taken as delta TF observed and one can be theoretical. Now what is observed is temperatures. We can measure temperatures by using thermometers. So this can be the observed value and so we can have delta TF observed for the above value. So the other value automatically becomes delta TF theoretical. Now we'll calculate I. For I we have the formula delta TF observed upon delta TF theoretical. Observed value is 0.51 and theoretical value is 0.279. Now let's take log for the numbers. First of all we'll take characteristic. Before decimal we have no number over here, but after the decimal very first position we are having a digit, so the characteristic is bar 1. For the second number also the characteristic is bar 1. Between these two we have division, so we have to subtract the log numbers. Now the log for 51 is 7076 and the log for 27 under 9 is 4456. So let us subtract 660,752, 1046 and 64 would be 2. Now bar 1 minus of bar 1 is nothing but bar 1 plus 1. So bar 1 plus 1 is 0. Let's find out the antilog for the number 0.26 under 2 mean difference 0. So the antilog for this number is 1828. Directly put a decimal after one digit. Now since Van 't Hoff factor I is a ratio, so it doesn't have any units. Let's start with pi. Pi is equal to MRT. KCl will be dissociating into K plus and Cl minus. Therefore, we have N dash, that is number of particles as 2. K plus 1 particle, Cl minus another particle. So 1 plus 1, 2. So pi equals to I into MRT. Now why I? Van 't Hoff factor, because there is a deviation. We are using an electrolyte. That's why we have to multiply the formula by I. Now this is taken as I MRT. since we are going to consider molarity is equal to molality because it is mentioned like that in the question. See, in the question it is written, assume volume of solution equal to that of volume of water. So molarity has to be considered equal to molality. So this will be equal to I, that is 1.828 into M, and what's M? 0.15 into R, universal gas constant 0.08205, multiplied by temperature 0 degrees Celsius, that is written as 273.15 Kelvin. Now let's take log. Before decimal there is one digit, so the characteristic is 0. After decimal, very first position we have the number, so the characteristic is bar 1. Similarly for this also the characteristic is bar 2, and for the last one before decimal we are having 3 digits, so 3 minus 1, that is 2. Now in between all these numbers we are having multiplication sign, so we have to add all these numbers in log. So the log of 18 under 2 mean difference 8 is 2620. Log 15 is 1761. Log 82 under 0 mean difference 5 is 9141. And log of 27 under 3 mean difference 2. Here we have to round it off and consider it as 2. So we are having here 4365. Now let's add this. So get 7, 8, 8, 7, and we carry 1 here. So 1 bar 1 0, bar 2 plus 2 0. So finally here we are going to get 0. Let's write it down. Now we find out the anti-log of 0.78 under 8 mean difference 7, and we get the value as 6148. Directly put a decimal after one digit, and this is osmotic pressure pi, so the units are atm. Hope you have understood the numerical. Thank you for watching my video.